Hello, everybody. I'm Andrew. This is Emil, William, and Stacey. We are Blob. So, we have a problem. The people of the A14 have been busy entering observational data into an app. So, basically, they're holding their app, they're going out on site, and they're just logging anything. This could be a spillage, this could be there's no cups in the cupboard, it could be anything. They're just logging loads of data. The thing is that when you just let people put data in, they just put things in their own language. So this could be sarcastic, this could be British English, and there is a certain amount of sentiment that is connected to that data that is picked up. So they've been looking at the sentiment of the data, and we've been trying to gain a better understanding of that sentiment. So if we move on to the next slide. We've used some technology to do this. There's 80,000 rows of these observation data, and we've loaded it all into Python. There is a library that connects to Python that's called TextBlob. Now, you enter a piece of text into that piece of equipment, and it will give the observation a score. So 1 is positive, and -1 is negative. This is where you input that, and it comes out. So we use that, and we use Power BI to present some of that data. We also did a bit of machine learning, so we took that data and we tried to predict what sort of outcome would come from it. Would it be positive or would it be negative? I'm just going to pass it on to Emil, who's going to be doing the next slide.
Hello. So we've passed in the data straight from the TextBlob into Power BI, and from there you can see that the dots in blue are good practice, and the dots in orange are hazardous practice. And you can see that it's slowly trending itself towards +1 and -1. But what we've also seen that there's a couple of outliers. So as you can see at the top, it says that it should be a positive outcome, but it's actually fairly negative, as it says that there's too many people using one welfare facility. The same goes for the second one, which is about Jordan has been moved from a gate to a gate, but it actually is a positive one. But on the other side is we've spotted a negative one that's been marked as a positive, right here. And iterating through that, we've been able to catch some of those outliers. I think that's it.
So using our sentiment analysis generated by TextBlob, we were able to generate new insights from the data. For example, we were able to identify which type of incident is generating the most negative response from the user. That will be, for example, public danger event or errant vehicle event. We are also able to identify which portion of the road is generating the most negative feeling among the user. That will be, for example, the central portion, the section 1 and the section 5. So this could be useful to determine which part of the road you should focus your effort to improve the sentiment of the user of the road. Next slide, please. In order to validate if our sentiment analysis was correct, what we did was to compare the sentiment score to the practice type entered by the user, which could be good practice or hazard. And as you will expect, when the user is registering good practice, this is associated with a positive sentiment in the summary and description part of the application. Since we are confident with our sentiment analysis, we built a model using machine learning to predict the practice type, which could be hazard or good practice, based on the other variable of the dataset, location, and our sentiment analysis, which allowed us to predict with 83% accuracy the practice type based on the sentiment analysis, which means that in the future, in the application, we could dispense the user to record the hazard or practice type. Instead, to approve the accuracy of analysis, we could replace this practice type with happy face or sad face, for example, which could help us to better determine the sentiment of our model. When, for example, we have keyword that could throw off the sentiment analysis. For example, some words such as digger gem, fell downstairs, or sarcasm, such as nice one, mate, you screwed that one up, could be mislabeled by the sentiment analysis, and adding another button could help to better predict the sentiment from the user.
So some of what we think we can do with this, obviously tying into the voice recognition app earlier, is actually if you don't need to fill in a form that says it's positive or negative, and you can just plain language respond to what your observation is, it helps adoption and helps drive people interact with technology in a way that is usable. It also allows us to get some insight into what people are saying in natural language, which also ties in from construction side as a big drive towards well-being, and which ties into how people feel on site. We don't normally capture that data, so actually if we're capturing some of whether people are feeling positive or negative in the language that they use while they're capturing their health and safety data, there's a really good insight there into stuff that at the minute we just don't have access because it's hidden within all this unstructured data. So it supports all the people-centric aspect to construction. So what we'd like to do taking this forward is to increase the number of data sources we have. Most construction companies that I've interacted with have a similar kind of app, so it shouldn't be that difficult to increase that and actually start to refine the data model to kind of teach it to speak construction. As we saw, there's certain terms which have neutral kind of sentimentality when we talk about it, but the language model's actually giving these a positive or negative value. Also do some trend analysis as to whether the subjectivity goes or the sentimentality value goes up over time, whether certain parts of day, certain parts of the week or month, bringing it in compared to other data sets such as, do people start to use more negative language in wet weather? All sorts of things that you can't just do with straight up data observations. And also forensic investigation. If there's an event that does happen, can we look into how people were feeling, looking at the language that they were using in the observations leading up to that event to see whether it could have been picked up and prevented beforehand. So that's some of the commercial applications that we've looked at.